All right, hello and welcome everyone. We're back again. Today we're going to be making a video sort of exploring molarity and exploring the use of this equation. Capital M for molarity or molar. Molarity is equal to moles of solute divided by liters of solution. Should mark this solute up here. And to sort of shorten this equation, shorten what we're writing out when we're writing the equation, often we'll write this equation as capital M, again for molar, is equal to moles of the solute divided by liters of the solution. Moles is equal to moles per liter. So let's go ahead and take a look at 3 examples of using this equation to solve problems. Let's read this first one. What would be the molar concentration of a solution containing 2 moles of sodium chloride with a total volume of 1.50 liters? So first, let's look at our information given here. We've got 2 moles of sodium chloride, that is our solute, sodium chloride, and we have a total volume of 1.50 liters. That's the total volume of the new solution. So let's write that down. We've got moles equal to 2.00, and we've got volume in liters. The liters is equal to 1.50. So let's go ahead and plug that into this equation here. Molarity is equal to moles per liter. When we do that, find that molarity is equal to 2.00 moles divided by 1.50 liters. And when we do that, pull out our calculators and divide, we find that the molarity is equal to 1.33 molar, or we would say that we have a 1.33 molar solution of sodium chloride here. That's simple enough, finding the molarity using the molarity equation from moles and liters. Let's move on here to a slightly different problem. In this case, it looks like we'll be solving for volume. So what volume of solution would be required to have a 2 molar solution? So this is our concentration here, 2 molar solution containing 5 moles of the solute. Now notice it doesn't give us the solute, but really it doesn't matter because it gives us the moles of the solute. If we were given grams of the solute, we would need to know the identity of the solute to determine the molar mass and calculate the moles, and that'll be covered in a later video. Here, let's go ahead and get started. Concentration is equal to 2.0 moles. We could write M is equal to 2.0, and we have moles equal to 5.0 moles of our solute. The equation, again, we'll be using moles, or rather molarity is equal to moles of our solute divided by liters of our total solution. But we need to rearrange. We need to rearrange this equation to solve for L, our volume in liters. So if we multiply both sides by L, we get liters times molarity is equal to moles. And if we divide both sides of the equation by molarity, we find that the liters are equal to moles of our solute divided by the molarity. So we can go ahead and plug our numbers in here. We get volume, or liters, is equal to 5.0 moles of our unknown solute divided by 2.0 molar solution. And we find that we have, or would need, 2.5 liters of solution. But wait, there's another way to solve this problem. And I sort of prefer the second way of solving it. We can treat this problem like a dimensional analysis. We're given 5.0 moles of solute. That's an amount. So we can start with 5.0 moles of our solute. And notice molarity has units of moles per liter, so we can use it as a conversion factor to convert between moles and liters, liters and moles. So in our 2.0 molar solution, that means that for every 1 liter of solution, we have 2.0 moles. Now notice, the moles cancel, and I'm left with liters of solution. So my answer here, 5 moles divided by 2, is still 2.5 liters. And this method sort of comes in handy when we start doing stoichiometry using the concentration of a solution. Finally, our last problem here, how many moles of silver nitrate are present in 250 milliliters of 0.5 molar silver nitrate solution? So we've got 250 milliliters. We'll need to convert that to liters. That's 0.250 liters. We'll write our information down. Volume is equal to 0.250 liters, and our concentration is equal to 0.500 molar. Now, the equation, again, molarity is equal to moles per liter, but in this case, we are solving for moles. So I need to multiply each side by liters, and I get molarity times liters is equal to the moles of solute. So I can go ahead and plug in my numbers here. The molarity is 0.50 molar, rather 0.500 molar, paying attention to our significant figures, multiplied by 0.250 liters, and we find that we have 0.125 moles of silver nitrate, AgNO3, in this solution. Now, again, we can look at this like a dimensional analysis. Let's take a look at how that would look. Again, the solution will be the same, but it's just going to look a little different. We're starting here with 0.250 liters. That's an amount, 0.250 liters. And we're going to use molarity as a conversion factor. We have 0.500 molar, which is 0.500 moles per 1 liter of solution. So if we set it up like this, we find, again, that we have 0.125 moles of silver nitrate, AgNO3. Now, hopefully you guys can see how this second method is going to come in handy when we start to solve stoichiometric calculations using concentrations and volume of solution. That's why I sort of prefer this method here, but both work and both will work when we're doing stoichiometry with these as well. Hope you guys enjoyed the video. Hope it was helpful. See you again next time.